So yesterday we did one-step equations. Today we're doing two-step equations. You guys did this last year, 8th graders?
Yeah, probably.
Did you guys do anything like that last year?
Kind of.
Probably did. I'm pretty sure you did. So when we're solving two-step equations, really when we're solving equations, we're kind of working backwards. So it's kind of like the opposite of order of operations. So we're working backwards to figure out what x is. So remember we're trying to get x by itself on one side. So we got a times 2 that we need to get rid of and a minus 5 that we need to get rid of. So if we're working backwards, so if we were going forward, we would do 2 times x minus 5. But if we're working backwards, we would get rid of the minus 5, and then we'd get rid of the times 2. So usually, and there are a couple exceptions, we'll talk about a couple exceptions, but usually you want to get rid of the plus or minus number first, and then you want to get rid of the times divide number second. So that's the general rule. There are a couple exceptions down in the B section. We'll look at those here in a little bit. All right, so what should I do to solve for x here? Plus 5, okay, and just like yesterday, I didn't make sure you all showed your work, but just like yesterday, I'm going to be mean and make you show all this work. And then after you add 5, that's gone. That's 12, and then how do I get rid of this 2? Divide by 2. You guys remember that from last year, right? So still not hard yet. We'll do some hard stuff. Although the B section does have some tricky ones, so we do need to talk about those. All right, but let's go ahead and jump in and get started. We'll talk about them when we get there. Number 1. Everybody got the bell work down, right?
Yeah.
Okay, you do need to write it down. I'm going to be going a little bit quickly, but I'll try not to go too fast. Let's do what we did yesterday, just kind of go around. Should I start with Paxton again?
Yeah.
Save 8th graders for last. Paxton, what should I do first?
Let's see. You should just work out the problems.
No.
Boy.
Alright, so 5 times 6.
No. Are you on the right page? We're on page 72.
No, okay, I'm not on page. I was on page 66.
Okay, we'll come back to you. Clayton, what should I do first?
Plus 10.
So I got 3x equals 24. You don't have to look at everything I'm writing down. Maybe just write it yourself and then check and make sure we're on the same page. That'll save you some time. And then what, Clayton?
Divide by 3.
Okay. Maybe I should write smaller. Okay, number 3. Paxton. Okay, does it matter that the C is on the right side? 3C plus 2? No. And if it makes you feel better, you could switch it around. But we're trying to get, is it a Z? Oh, it is a Z. We're still trying to get the Z by itself. So Paxton, what should I do first?
Okay, so minus 2. And then divided by 3.
Number 5. Negative 4C plus 9 equals 41. All right, Jaden, what should we do first?
You should do minus -9.
-9.
And then you should
Divide by -4. What is 32 divided by -4? -8. It's gonna take up a lot of room, I know. The assignment's so big, we might even need a second page. But I wanted to get down to those trickier ones, and I also wanted to do a few word problems, so felt like I had to kind of make it long. But they don't take that long, do they? It's not too bad.
Yes, they do. They take a very long time.
Easton's very upset. X over 5 minus 13 equals. Alright, Roman, what should we do first?
add 13.
You guys might check and make sure I don't. Occasionally I might copy the problem down wrong. Or you might copy the problem down wrong. So if I do, feel free to point it out.
Would you multiply by 5?
Hold on. -84 plus 13, so it's kind of like a tug of war. The negative's going to win by a lot. How much does the negative win by? Basically, even though this says plus, I'm subtracting those two. So it's -71. And then what'd you say, Roman?
Would you multiply by 5?
Yeah. So this does have an X on it, so I'm not going to use an X for my time symbol. Dot is not the best symbol in the world because it just doesn't show up very well, but I don't know. I don't have a good answer to that. So 71 times 5, 7 times 5 is 35, so 355, and it is negative. Don't forget that negative because I will count it off. How can I know for sure whether I got it right?
Plug it in.
If you plug it in, it should work. You might want a calculator. -355 divided by 5 minus 13 should come out as -84. Okay, P over 4 minus 9 is 13. Write that right? Yeah, okay. Easton, what should we do first?
Add 9.
Now what?
Times 4.
Am I going too fast? Any
No.
complaints? Okay. Sometimes. Alright. Well, if you wanted to, you can go back and watch the video. Probably won't want to, but number 11. 1.5R. You can get ahead of me by copying the problem down while you're waiting for me. Okay. Is it Skylar's turn? What should we do, Skylar?
Subtract 2.3.
Yeah, it's probably best not to like try to copy everything I'm writing because you keep having to look up and down.
4.5.
It's probably the best to try to do as much as you can on your own,
You did not.
and you won't fall behind. Oh boy. Did you guys know that 15 went into 45 3 times? You knew that. Of course you knew that. All right. Word problem. Solve using the problem. These are actually easier word problems because they're only one step. But when we get to the B section, they're 2 steps. So it's kind of like the 2 word problems from yesterday. So Gianna, we're going to write the equation and solve it. Okay? So we're not just going to put the answer. What should we write? A number added to 27 gives negative 14. What should I write for that?
A number, which is a letter, W. Plus 27 is equal to negative 14. W.
Okay. These actually might be easier because it's just one step. So, minus 27. Yeah, negative 14 minus 27. They're both going down, down. So it's kind of like adding 2 negatives together. If you get confused, I would just plug it in the calculator to make sure. Negative 14 minus 27. Two negatives make a positive when you multiply, but when you add, they just add up to a bigger negative. 15. Okay, Carolyn, the difference of a number and negative 9 is negative 74. How could I write that?
Difference between number and negative 9, would that be 9 minus, negative 9 minus the number, or the other way around?
The other way around. The only one that's backwards is if it says less than, or they subtracted from would be backwards. I don't think they say subtracted from, but yeah, it's just in order. So it's the number. You guys might make a mistake on this one because it's n minus negative 9, not n minus 9. Equals negative 74. Okay, and what does n minus negative 9 actually mean? N plus 9. So you might just write down n plus 9 so you don't confuse yourself. So how do we get rid of the plus 9? Minus 9. Negative 74 minus 9.
Negative 80.
It's kind of like an adding problem. Okay, Olivia, where are we at? 17. Laura is
When?
6 times.
When Laura is.
When Laura is 6 times as old as she is now, she will be 84. It's a little more of a thinker, isn't it?
Is it 6x equals 84?
Yeah. I would think of it like 6 times now equals 84, but yeah, same thing, right? 6 times her age now, or maybe A for age or something, equals 84. Anyway, what do we do there, Olivia?
You divide by 6.
Divide by 6. So, how many times did that go? 14. All right. 19, Sarah. Kent has 3 times as many stamps in his collection as Jen does in hers. If Kent has 243 stamps, how many stamps does Jen have?
Would you go 243 over 3?
Okay, that's how you solve it, but I want to write an equation for it. So Kent's stamps, let me write it this way. Kent's stamps is 3 times, what was her name? Jen. So it's kind of like that, but we know how many stamps Kent has, right?
Yeah.
So I don't really need a variable there. 243 stamps is 3 times Jen's. So yeah, you would divide by 3, yes.
Would it be
what's that come out to, 81? Alright, time for part D, the trick questions. Okay. This is a very important trick. 21. 22 has the same trick, so watch out. Maybe take good notes here, and then you won't get caught on 22. Oh, we got to the 8th graders. We'll save the tricks for you. Well, maybe I'll open this up to it, unless you want to try it, Emily.
Sure.
I'll open that up to the class. What do you guys think we should do first?
Plus the W.
Okay, yeah. 9th graders, you guys should have seen this before. 8th graders, probably not. Or maybe once, I don't know. So here's the problem. This is 17 minus W is the same thing as 17 plus negative W, right? So we're still trying to get rid of a added 17, even though they put 17 in front. How do I get rid of an added 17 or positive 17? Subtract 17. Okay, that's not the only trick, however. Okay, the 17 goes away, that's good, but what do we have left on the left? Negative W. Minus W is like a negative W. Same thing is going to happen on 22. On 22 though, how would I get rid of the negative 24?
Plus 24.
You plus 24. It's basically on 22, that's an added negative 24. What's the opposite of adding negative 24? Adding positive 24. So anyway, you get rid of it by adding 24. Negative 13 minus 17. I'm not done yet, because I don't want to know what negative W equals, I want to know what W equals. So, what's another way of thinking of negative W?
Just look at
Negative 1W. Okay. How do I get rid of negative 1?
You add
Flip it.
one.
Okay, if you divide by negative 1, this is multiplied, right?
Yeah.
It's basically dividing by negative 1, but what happens when you divide by negative 1? It just switches the signs. Like 30 divided by negative 1 would be negative 30. Or negative 30 divided by negative 1 is positive 30. So really all we do is switch the signs. Okay? You could write down that we're dividing by negative 1. We're actually multiplying by negative 1 does the exact same thing. But basically the signs just switch. Positive W equals positive 30. Because if negative W equals negative 30, positive W equals positive 30. Just switch the signs. Yeah.
Like, so wait, could you do it a different way? Like if you plug in that, it would be negative.
So like check the answers, is that what you're saying?
No, like it would be negative 30 put in for W.
Yeah, yeah. So if it was negative 30, it would have become, if it was positive 30, it'd become negative 30. Wait, what are you saying?
Never mind, I realized it.
You got it figured out. Yeah, if this had been a positive 30, it would have become a negative 30. Is that what you're saying?
Yeah.
Okay. Sure, okay.
Sure, but there's like if I'm professional assessor.
Did you mean if that was a negative negative?
Yeah, like if you put it into the problem, it'd be minus a negative 30, so then it'd just be a plus.
Oh, yeah, I see what you're saying. Yeah, okay. You were saying check the answer. Well, negative 30 is not the answer, 30 is the answer. So if we plug in 30, 17 minus 30 is negative 13. Yeah, if I had gotten negative 30 for the answer, it would have been 17 minus negative 30, which would be like adding, which would be wrong. But we got positive 30, which does work. 17 minus 30 is negative 13. All right. There really isn't anything very special about 23. Just, you do the exact same things, just don't let the decimals freak you out. That's all you can do. So, Emily will give you this one. What should I do first, do you think?
You're gonna add 4.7.
Right. Well, this is kind of hard to do in our head. Hard for me to do in my head. Even though this is adding, it's kind of more like a subtract because we got a negative up there. So what would that be? 13, 12.92? Is it 12.92? I don't know.
12.98?
Oh, 98, yeah, that's right. Well, yeah, I probably should have, yeah. But it is negative because the negative was bigger. If I wanted to do it by hand, I would have had to write it out. 6.8. Okay, now what, Emily?
You would divide 6.8.
That goes away. That doesn't come out very nicely. Which makes me think, did we make a mistake? What does that come out to?
Not a number.
Did we make a mistake somewhere?
Well, okay, I put.
Did I copy it down wrong?
Yeah, I think it's negative 12.92.
Oh, it was a 2.
Yeah.
I got one.
Oh, okay.
Wait,
You
is it
lied.
All right,
Well,
now,
even I was questioning myself. I was like,
now what is it?
So it's negative 1.9.
Okay. Um, 25. Okay, y divided by 3.7 minus 1.8. What should we do first, Corey?
Add 1.5.
Add 1.5. Oops. So we got, that's gone. So I'm basically subtracting, but the negative wins. And now what, Corey?
Times 3.
I'm gonna let you guys do it with the calculator, I don't wanna. What?
Negative 4.81.
Negative 4.81. All right, 27. If all right, Sophia, what should we do first?
We add 1 over 2.
Add 1/2. Okay, well, these both go into 10, so I could change this into 8 tenths plus 5 tenths. So that would be 13 tenths. And now what do we do, Sophia?
Divide by negative 2 over 3.
Right, so on your calculator, you can plug in 13 tenths divided by negative 2 over 3. Or if you're doing it by hand or on a calculator, you could also plug in 13 tenths times negative 3 over 2. Right? So since I'm doing it by hand, I have to do it this way. That doesn't reduce 3 and 10, 13 and 2. So it's just top times top, 39, 10 times 2, 20. So it's negative 39/20. So since it's a fraction problem, I want you to put the answer as a fraction, not a decimal. If you get a decimal on your calculator, you need to hit the fraction button. If you don't know how to do that on your calculator, you can ask, and I'll help. You guys done? Where are we, 29? Alright. Okay, here's another weird one. So 29 and 30 are kind of the same. 30 is quite tricky because it has a minus y on it, kind of like number 21. So be careful on 30. But 30 is a lot like 29. Okay. So at the beginning of the lesson I said normally you want to get rid of the plus or minus number first and then the multiply divide number next. This is an exception because the division bar does weird things. If the whole left side is divided by 2, you can't just add 5 here because this 5 is not just worth 5. It's actually worth 5 divided by 2. This x is not just an x, it's worth x divided by 2. So we can't just plus 5 here. If the whole left side is divided by 2, you need to get rid of that first. So how do I get rid of divide by 2? Times 2. So what happens when you multiply by 2 is basically that. It goes away. I'll just write it down here though. Times 2 times 2. Those go away. Yeah, add 5. So it's kind of backwards from all the rest of them. Thirty is probably the trickiest one. Because not only do you multiply by 2, then you would subtract 5, then you have to switch the signs. So there's kind of 3 steps on 30. Okay, 31, a few more word problems and we're done.
Wait.
The difference on these is that they are 2-step. Alright, so Eli, wait, you did, yeah, Eli, you're up. So the sum of 47 and 3 times that number is 68. So Eli, what does sum mean?
Add
Okay, so what will this one be?
47 plus 68, and
Oh, just skip something. What are we adding 47 and
3 times, 3 and
3 times the number? And then is, yeah,
equals 68.
is your equals, and then 68. All right, Eli, what should we do now? It's written a little bit backwards from most of them, but
Subtract 47.
subtract 47 is the first thing. But we're doing the same steps, doesn't matter that the 47's in front. Then what?
Divide by 3.
How far did I say? 36. So we got a couple left, a couple odds left. You should be able to do it by yourself. You're probably doing the evens while I'm doing that. You're,
No, I'm not.
you're getting behind. Okay, 33. All right, this might be kind of a new idea for us. How many nickels must be added? So This is one of those problems you might be able to do without algebra, but we need to practice writing it as an algebraic equation. It's a little bit harder, so some of you might get confused even without the algebra, but we need to practice with algebra. So how many nickels must be added to $2.47 to make a total of $3.12? Okay, pause. Let's say I had N nickels in my hand right here. How would I figure out what's the value of the nickels in my hand?
5 times.
Okay, 5 cents times N, right?
0.
So the value of the nickels is represented by 5 cents times a nickel.
Where did you get the phone? 0.05.
Each nickel is worth 5 cents. So you take 5 cents times N. N stands for the number of the nickels, doesn't stand for 5 cents. Does that make sense? Pun unintended there. Good thing Will's not here. Okay, anyways, that's the value of nickels. So it says we have $2.47 already. And we're adding to that the nickels, which is worth 5 cents per nickel. And we want that value to add up to $3.12. Does that make sense? It's going to happen every time. Sure? Yeah.
It does.
$2.47 plus 5 cents times however many nickels we have. So if I had like 10 nickels in my hand, I'd have 10 times 5 cents in my hand. Anyways, now it's a normal problem. So Paxton, what should I do?
Minus 2.47.
Minus 247.
Are there any more like that?
Yeah, 34. $34, $35, $36, they're kind of like that. Let's see, all right, we'll do this.
5 cents.
Okay, how many times does 5, go into 65?
13.
So what's a 13 mean on this problem?
How many nickels there are?
You need 13 nickels to get that much money. 13 more nickels. Hmm.
We have 13 nickels.
Okay. All right, 35. David is charged $19 a month and 5 cents per minute for his pay-as-you-go cell phone plan. If his bill was $21.35, how many minutes do you use? He's charged per minute. So no matter how much he uses his phone, he has to pay $19 every month. Plus, on top of that, he has to pay 5 cents times every minute he talked. And altogether, his monthly phone bill was $21.35. Anybody think they might know what that looks like as an equation? So I'll say it one more time. He has to pay $19 no matter what. On top of that, he has to pay 5 cents for every minute. And in total, he pays $21.35. Gianna?
So 21.35 is equal to 19 plus 5 cents per minute, so 0.05 times minutes.
Right. 5 cents per minute. You're going to have to pay 5 cents times however many minutes he was on the phone. Yeah. Okay, so, so I'm guessing your cell phone maybe costs about $20 a month and you don't get charged per minute or something, right, like that, right? Okay, so how much are you gonna have to pay this month? 20 bucks. But they're saying on this plan, besides that, you're also gonna have to pay 5 cents for every minute that you talked. So let's say you talked 20 minutes. That wouldn't be very much, but let's say you did. So you'd have to pay 20 times 5 cents for that. So in total, you'd have to pay 20 times 5 cents plus the $20 just for having fun. Playing. Right. Doesn't tell us how long, so that's why we left a variable right there. And we gotta figure that part out. We can do algebra to do it. So, what is my first step to solving this? Subtract 19. Okay, it's all kind of backwards, but we're gonna do the same thing. We're trying to get m by itself on the right side over here. So get rid of that plus 19. Now what? Divide by 0.05. Dividing 2.35 by 0.05 is the same thing as dividing 235 by 5. So
47.
So that means he talked, or she, or whoever. David, he talked for 47 minutes. In a month? That's not that long in a month. Well, you guys probably text more than you talk. Alright. Let's get it done. Go, go, go.